Alrighty, so we're going to do some review over our transformations from yesterday. Okay, please make sure you're asking questions if you have any about these transformations. We're going to be seeing a lot of these. Also, please make sure you're watching our videos in Edpuzzle. That way I can actually see if you're watching them. That would be great. And then last but not least, I will be updating the Google Forms today so that you'll actually be able to do the Google Forms over the transformations. I'm so sorry I did not get that posted yesterday. Alrighty, so looking at these three functions. Okay, whenever we state transformations, we always compare it to the parent function. So we will always compare to y is equal to x. Okay, so we want to know how did we go from y equals x to our new function, which is y equals negative x. So the parent function I'm going to write in blue each time. Our parent function looks like this. So I want to know what happens whenever I go from this parent function to my new function. And if we remember from yesterday, anytime we have a negative in front of our x, every single time, my new function is I'm going to write in pink. Every single time it reflects it over the x-axis. So it looks like this. If you put it in the calculator, you'll see it looks like that right there. Okay. So anytime we see an x or a negative in front of the x, we know, hey, it's been reflected over the x-axis. That's how this is different than the parent function. Yes, you need to write the whole thing. Don't just write reflected, because you're eventually going to get to whenever you reflect over the y-axis or when x is equal to 1. So you'll actually reflect over a lot of different things. So that's why we have to be specific. All right. So anytime we see the negative, we know that it's been reflected over the x-axis. Now, it's not only negative, but now it's a negative 3. So parent function looks like this. If I put my new function into the calculator, it's going to look like this. So I want to know, how did I get from my parent function to this new function? Okay, what happened to the parent function? Well, we already know the first thing that happened to the parent function. It was reflected over the x-axis because it's negative. Circle, there we go. The second thing we notice is it's not just an x anymore. Now it's got a negative 3 up front. So that 3 is going to be really important. Okay. So anytime it's a whole number, so a number bigger than 1, that means it makes it super steep. Okay, think of a mountain. This is a really steep mountain. If I'm climbing up that mountain, it's going to be rough. Okay. So anytime it's super steep, that means it's been vertically stretched over the x-axis. All right, that's the only thing different with this one compared to our parent function. So now we're going to look at this new one. So now we still have the negative 3x, so we know, hey, it's still been reflected over the x-axis. It's still going to be vertically stretched. Wow, I am just reading what I wrote. Guys, go back. I am so sorry. If anybody caught that, thank you. If not, that's fine, because I know we're still learning and this is all brand new, but I should not have written vertically stretched over the x-axis. That does not make sense. Wow. I'm so sorry. It should have said vertically stretched. Our number was 3, so we should have said by a factor of 3. Man, how did I do that? I'm sorry, guys. Hopefully I don't do that again. All right, so looking at our new one, it's still been reflected over the x-axis. It's still been stretched by 3, but now we have this new piece too. So if we have our parent function, if you put our new one into the calculator, it's going to look like this. Oops, nope, not like that because it's steeper. There we go. It's going to look like this. So we want to know, how did we go from the parent function to the new function? Well, it's going down, so we know, hey, it's been reflected over the x-axis. We know the number up front is a 3. And if we look at the graph, it's steeper. So we're going to say vertically stretched by a factor of 3. And then last but not least, we went from 0 all the way up here. Okay, so that means that the whole graph was moved up. Okay, so we're going to say it was translated up how many units? 4 units, because we added the 4. Okay, so we're looking for these 3 things every single time. Is it reflected? Is it stretched or compressed? Or is it shifted or translated up or down? Okay, and that's why I have all those prompts on those problems in the homework. So please make sure you're checking for those. Alrighty. Okay, so that's all I've got for your check-in for our linear transformations. Okay, you can move on to your notes.